Hello, this is Sam Rzai, and in this video I'm going to cover the software concept of open APIs. We're going to go over what they can provide to an organization, along with some of the risks associated with them. I'm also going to go through some of the most popular API architectures that are currently being used in the industry, as well as some simple examples on how to use them. So what is an open API? Well, first we need to understand what an API is. An application programming interface is a set of software rules that define how a client or user would communicate with the server. The types of communication can usually be summarized into reads and writes. The API is the one responsible for actually translating and transferring the data between systems. A conceptual example of an API that I like to think about is a server at a restaurant. When you order your food from the menu, the server is responsible for relaying your order to the chef, acquiring your food, and bringing it back to the table. This is how an API works, except the chef is a server or database, and instead of food, you are requesting to read or write data. Now with all of this, an open API is simply when these access mechanisms are made publicly available on the internet for third-party or individual developers to use freely. This does require the organization to create public endpoints into their systems, however that just means extra security needs to be put in place around these access points. Now that you know what an API is from a high level, let's go over some of the reasons as to why an organization would want to implement something like this. You can look at the benefits of an open API from two perspectives, the organization as a whole and third-party or individual developer benefits. Starting with the benefits towards the organization. The first is to expand the user base of their services without the cost and time required to develop with niche software tools. Second, it can also create new avenues for revenue through things like licenses or fees for additional APIs, tools, or data. It also acts as marketing for a company by publicizing its name, data, and services. An open API will also eliminate barriers for clients by enabling quick and easy integration of an organization's data into their system, as well as allowing for their own customizations. Another huge benefit from an open API is the ability to utilize customers' insights and usages. Understanding how users are interacting with your data and services and the metrics that they care about the most can show you what path to focus on within your organization. These usage logs can show you the most valuable parts of your interface and help make improvements in the most valuable places. And finally, an open API simply promotes innovation and collaboration. From online forums to servicing new industries, enabling customers to use an interface how they want with little limitations creates new ideas that can be developed and shared. In fact, in some cases, API providers have even incorporated functionality that their end users have developed. Moving over to the benefits to a third-party or individual developer. An open API helps provide an abundance of public repos and online forums discussing and reusing code, and this results in less time spent fixing mistakes. An open API can also help reduce dependencies between development teams and certain applications or components. Harnessing data from a server or database can require extensive configurations and connections. However, with modern API architectures, it can be done in a single line in varying coding languages. And finally, when using an open API, a developer can still use their own software tools alongside the API and are not restricted in any functionality. For the most part, open APIs are great tools. However, with any application released to the public, there are potential risks and drawbacks. Firstly, an open API imposes security risks to an organization by accidentally releasing private company data. It can also be used by hackers to penetrate an organization's networking infrastructure by acting as an access point into main servers. Therefore, companies need to take the time to put extensive security around these services. Along with developing security, there is also overhead associated with maintaining an open API. The cost and time required to address things like bug fixes, version releases, and customer service need to be taken into consideration as well. If not, poor API management could damage a company's reputation and cause its users to lose confidence in their software capabilities. And finally, an open API does require communication with main internal servers, so depending on the number of users and pre-existing traffic on those servers, internal system delays could arise, affecting a company's operations. From the perspective of the developer, the only main risk that comes with an open API is the heavy dependency on the company. If the company decides to change the terms of use for its API, or, for example, charge a fee for licensing the API, the developer has no choice but to accept it. Now let's take a closer look at how exactly APIs work and the architectures that they use. Most modern API architectures fall into two categories, REST and SOAP. Both APIs use HTTP protocols such as GET, PUT, POST, and DELETE to indicate the type of command. SOAP APIs are definitely an older architecture, however they are still used in some organizations. One of the main reasons for this is because the SOAP architecture was standardized by the Internet Engineering Task Force to support different types of expansions. This provides the architecture with advanced security features and more complex algorithms. However, SOAP's biggest asset is also directly related to its biggest drawback. SOAP was made strictly to use XML to create and format its messages, both requests and responses. Now, this XML is what enables all of its fancy features, however, it also makes it much more inconvenient to write and parse, especially when compared to its lightweight counterpart REST. As mentioned, REST also uses HTTP to communicate over the internet. However, it's not constrained to only return XML. It's able to return a variety of formats, including JSON, CSV, RSS, and more. The syntax to send a request is also simplified to be a single URL, as opposed to a block of XML. Because of these convenient factors, most organizations are moving towards REST because of the incentive of easier learning curves to its customers. Next up, we're going to go over some examples in Python to use both of these architectures against some free public open APIs. Starting off with the SOAP architecture, we're going to make a post command to an open API hosted on webservices.orsprong.org. This website is a web service that stores a collection of country information such as 2-letter ISO codes, capitals, currency, language, telephone codes, and more. In our code, we specify the host URL, the structured XML payload, and the content headers to allow for proper parsing. As you can see, the XML payload is quite dense and not necessarily intuitive. If you take the time to decode this payload, it's actually quite a simple XML block. However, that's because it's not doing much in terms of functionality. It's simply retrieving the country code of the input US. What I want you to take away from this is that although this XML format allows for a lot of extra customization, enabling for more sophisticated payloads, it also increases the complexity and time taken to understand and use. Finally, we send out the payload with the appropriate parameters using an HTTP post request and print the response. Since this is a SOAP API, the response is also in XML. And after digging through it, we can see our returned phone code for the US is 1. Next, we're going to use Binance's REST API to query some data about the crypto ticker BNB-BTC, which is Binance Coin. All I had to do was find and create the request URL using the Binance REST API documentation on Google and insert the appropriate symbol into the field. As you can see, this format for requests is much simpler and easier to work with than a SOAP architecture. When we run this, we get the following JSON response from the endpoint. I didn't format the response for displaying purposes because it would be too large to show on the screen. However, notice that I was able to receive back so much data from such a simple command. Next, take a moment to stop and think about what a software developer would want to do next. Think about it from a very conceptual point of view. Don't worry too much about the specific data. Instead, think about how we could take advantage of a data stream like this. What comes to my mind is to first start off parsing this JSON block and wrap it with a data model or class to make it more readable and usable within the code and not just a block of formatted text. Next, we could place that logic into a loop and parse and assign data objects for a collection of tickers. From here, we would have a collection of data objects, each associated with a different crypto to perform more operations on. We can begin to look for similarities or trends within the different instances and start to develop more metrics and conclusions from them. This is one of the core ideas behind how big data platforms work and how they derive data from parsed raw data. However, that'll be for another video. In the meantime, let's wrap up what we've learned about open APIs. Open APIs are public tools that use mostly HTTP to transfer and translate clients' data requests to and from a server. They promote innovation and collaboration between developers and also bring a lot of recognition to the hosting organization. They do come with some risks, as most things do, mostly security and API management, which can both be addressed with proper planning and resource allocation. We went over two of the most common API architectures, REST and SOAP. In today's fast-moving software world, more API architectures are being developed as we speak. However, in most established organizations, these two architectures are the main players. Using an open API can seem very intimidating and technical at first. However, with a couple Google searches and some quality documentation, it becomes a much more doable task. For this reason, we used Python to generate an example request for both types of architectures to see them in action and compare both formats. And finally, we quickly thought about how a developer could expand on an open API's capabilities to generate a more valuable piece of code or even product. If you have any questions or want to learn more about this topic, feel free to reach out to me at samrazai@gmail.com, and I'd be happy to discuss more with you. Thanks for watching.